Hello everyone. This time we will show you how to create a new implant library by ourselves. First, we can open the implant library in the Utilities, Implant Library icon. Then we can get a new UI. This is the implant library of WorkNC. On the left side of the library, it is the implant list. Customers can see all of the implant system existed in the software. On the middle, it is the geometry display of the chosen implant. On the right side, it is the implant geometry parameters setting. We can build or modify the implant library here. On the bottom is the implant milling sequences associated. All of the implant must be associated to a sequence to mill. Now let's start to create some demo case, which is often used. First, we create a new folder to save our demo implant. Name it whatever you want. Press the Add button to add a new implant library. Choose the first one, Implant Connection. Then we need to add a reference name. Don't use any strange character. One common bug is the B and B system. Don't input and. The second line is only the comment. You can input anything for your memory, or keep it empty. The same, no strange character. Now we can start to build the library. It contains 3 parts. First is the internals. We should build the screw tunnel geometry under this list. Second is the externals. We build the connection under this list. The last one is the cap. It is a protection surface for milling. It is similar like externals. Let's start from the internals. Press the green cross to add an element. In the list, here is some different type of element. The more often used is the cylinder, cone, and polygon. We create a cylinder first. It is easy. We just need to input the height and diameter. Then we get a cylinder in the display. Go on to create a cone. For a cone, we need to add 3 parameters: top and bottom diameter, and the height. Then, it will calculate the angle automatically. In the end, we create another cylinder to finish the screw tunnel. NoLock. We get an internal screw tunnel of an abutment. Now let's talk about some key points. First, the 2 diameters must be bigger, at least 0.1 millimeters bigger, than the drilling tools your machine use, and the screw you measure. Second, if the screw is flat without angle, here can be no cone. But if the screw platform has angle, we must make sure the angle value is perfectly fit the screw. The diameters of the cone must be the same as these 2 cylinders close to it. Last, the diameter of the bigger screw tunnel is not important. It will be modified in the true case by STL size. Input. Take care. The internals of the abutment should have only 2 or 3 elements totally. Otherwise the toolpath of milling will crash. Now, let's switch to externals to add the connection. First, add a cone as well. Once we add an element in the externals, it will add automatically a flat surface to link the externals and internals. Now we add a polygon. It is very important for abutment geometry. First, we set the height of the polygon. Second, we need to define how many sides this polygon have. In most cases, it is 6 sides. Then we need to input the inscribed diameter. It is the distance of the opposite side, and it is also the value we measure by the calipers. With these three values, we can get the display. We need to make some optimization. Press the corner icon. Here are 5 different types of the corner setting. Use the one you want. You can test it by yourself. All of the element type has a radius chamfer setting. We can create a chamfer for both sides if necessary. Add one last cone to finish it. Now all of the geometry is ready, but it is not the end. We need to add the cap. For the cap, we press the icon, generate the cap from externals. To copy the external geometry directly, to avoid the double work. Then the cap can be seen. We can stop here, or modify the diameter of the polygon, to make the milling result more stable. Normally we add 0.06 mm bigger. It depends on the machine accuracy. Now all of the geometry is done. We set a milling strategy for this part. Press the bottom, add sequences, to make setting. First, choose a material. Then, choose an existing template. For abutment, normally choose T_L. Then here will appear setting result. It means if we use this implant library to mill titanium material, it will use the milling strategy T_L. In the end, let me introduce you another element type, extrusion. It is for some strange irregular geometry like Nobel replace, Straumann or Megagen. For this type, we need to define the height and import a 2D closed profile curve to extend. If you have no ability to get this curve, please contact your supplier or WorkNC teams for help. Now, let's talk about the NoLock implant library quickly. It is easier than abutment and almost have the same rule. First is the internals, same, 2 or 3 elements maximum. All of the diameter is at least 0.1 mm bigger than screw and drilling tool. For externals, in most cases, it remains only 1 cone. For cap, it is exactly the same as external, nothing to change. For the milling strategy, NoLock library, use the template T_NL. Next, we will start to create a multi-unit library. Different with abutment or NoLock, most of its geometry is under the list of internals. This part of geometry don't have a high request for accuracy. You can modify the diameter if the fitting is not so good. Then we add a cylinder to pass the screw. Take care, this cylinder diameter must be bigger than 1.6 mm, even if the screw is small, to make sure the tool milling. And one more cylinder, 4th bigger screw tunnel. The same, it must be bigger than the screw and drilling tool. It is almost finished. We need to make some optimization. For the type with flat screw platform, we need to add a small cone. This work is to make all of the implant system, too. Use the same milling sequences. It is very, very important. Otherwise, you will get a wrong milling result. Switch to externals to build a flat surface. Switch to cap. One click to copy externals. One last step, add a chamfer on the internals. It is not mandatory. It will avoid some collision if the bridge has a big angle. In the end, add a milling sequence. Choose titanium, T_mu, and finish this job. Now we create a multi-unit geometry. We use a polygon type, for example. Add a corner. Make a chamfer. Add a flat surface. Add a small cylinder to instead the screw hole. Take care, no matter which system you want to mill. Keep the small cylinder diameter is 0.05 millimeters, height is 3 millimeters. Don't worry, the milling strategy will larger the hole in the true toolpath. This strange setting is to avoid some collision with the abutment library. So just remember and do it like this way. Then the cap, nothing special, just copy. Then we save and choose the sequence. Here will be 4 milling sequences to choose. T_mu_M14 or M16 or M20. It depends on which size of the screw this system use. This is all of the training video about the implant library creation. Thank you very much for your watching. If you have any problem, please contact with me with my email or WeChat.